Dow Corning brand silicone hot melt adhesives give manufacturers more options when it comes to assembly and production. These reactive moisture cure adhesives are applied as a hot liquid melt that cools at room temperature to quickly form a strong yet flexible bond. Today we are going to demonstrate one of our hot melt adhesives, as well as show some of the many benefits these materials have for assembly and production.
Before we begin the demonstration, it is important to go over proper safety protocol for handling these materials. Today I have assembled everything that I need for this demonstration in this tackle box. The safety equipment that I will need for this demonstration includes safety glasses, heat-resistant gloves, and long sleeves. Additionally, I've brought nozzles, dispense cups, a spatula, a screwdriver, pliers, rags, substrates with cured material on them, my hot melt material, and the hot melt gun. These hot melt guns do get hot. The set point temperature is 140 degrees Celsius, so it's important to wear heat-resistant gloves and to prepare for handling all the various parts that will be at or near the set point temperature of the gun. This material does come in many different packaging sizes, such as drums, pails, and cartridges like the one I'm using today. To start my demonstration, I'm going to puncture the front end of the cartridge. Then I'm going to completely remove the back cap and the desiccant material. These silicone reactive hot melt materials use a moisture cure system, which means they begin to cure immediately upon opening at a rate of 1/4 inch every 7 days. Next, I'm going to add the nozzle to the end, being careful not to over tighten the aluminum nozzle so that I don't strip the threads. Now that the cartridge and the nozzle are ready, I'm going to insert them into the hot melt gun. As you can see, this gun is cold. It will take approximately 45 minutes to warm this material to the proper set point temperature. There is an option for a preheat to 100 degrees Celsius. From that point, it would only take an additional 10 minutes to heat the material to the set point temperature. It is important to note that if you do the preheat, not to exceed 100 degrees Celsius, because at that point the material will begin to flow, and when you go to puncture the nozzle, it could create an issue. In either case, it is important to place a dispensing cup underneath the nozzle in preparation for the material to flow. While the material is heating up, I want to go over some of the benefits of these Dow Corning silicone hot melt adhesives. One of the benefits is that these materials can adhere to many different low surface energy substrates, such as polypropylene, polyethylene, polycarbonate, ABS, and Teflon, and they have the same amount of adhesion to all of these substrates. Additionally, there is no need to pre-clean or prime the substrates before application of the material. One of the other benefits with these materials comes with the ease of application, which can enable enhanced productivity. When compared to a competitive option like tape, the application of Dow Corning silicone hot melts can be quicker and offer a reduced footprint, which can lead to an improvement in total cost of ownership. Additionally, these materials offer flexibility with extended open times and the ability to rework if needed. As you can see, the material has begun to flow out of the nozzle. This indicates that the material has been brought to the set point temperature. You might be wondering if it is possible to reduce or eliminate this flow, and the answer is yes. In large-scale production, robotic equipment is installed with devices that can control this flow much more precisely than the manual gun we are using today. During my demonstration, I want to be sure to make 4 points. I want to make a point about the open time, the instant green strength versus the full adhesion, the reworkability, and the reassembly. I'm going to start with the open time. I have my substrates placed here. The first thing I'm going to do is dispense the material onto each of the 3 substrates. I'm going to wait to assemble them because I want to show that you do not need to assemble the substrates immediately. In fact, you have 15 minutes of open time with this material. At 15 minutes, the material begins to skin over, which only slightly hinders the material's ability to wet the surfaces of the substrates. Now I want to demonstrate the instant green strength. So I'm going to take the substrates that I dispensed the material on and adhere them to substrates that don't have any material on them. To do so, I'm going to place them together and apply some force to allow the material to wet both surfaces. Now I have achieved full instant green strength with these substrates, and I want to compare the strength to a part that has a fully cured sample on it. This material will take 36 hours up to a few days, depending on the bond line, to fully cure and gain full adhesion. It is possible to rework the material right away. Whereas with a fully cured sample, you have much more strength. If some adjustment is needed, it is possible to reheat the substrates to allow for easy reworkability for up to 24 hours. Because of the moisture content of almost all substrates, reheating weakens the adhesion and allows for easy reworkability. When demonstrating reworkability and reassembling the substrates, it is important to apply some force to allow the material to re-wet the surfaces. Now that we have finished the demonstration of Dow Corning silicone hot melt adhesives, it is important to unplug the gun and allow it to cool for 30 to 60 minutes prior to disassembly. Once cooled, you can disassemble the cartridge and the nozzle. To remove the nozzle, I will use the pliers. And the spatula to clean out as much of the material as I can. Then I will finish the cleaning process with my rags and a silicone solvent such as DS-2025.
We hope you found our hot melt adhesives demonstration useful. Here is a summary of the benefits of the product. Moisture cure. Compatible with many plastic and metal substrates. Instant green strength. Ease of application. Open time and reworkability. Long-lasting protection against environmental contaminants like chemicals, dust, and moisture. Natural flexibility that can help enhance shock and impact resistance. Can help lower total cost of ownership. For additional information on our silicone hot melt offerings, please see our website.